So on Friday we learned how to solve these systems of equations by graphing. So as long as you use that intersection feature in the calculator, then graphing will always give you an exact answer. So graphing is an okay way to do it. However, sometimes if the y's are not already by themselves, or if they take a little time to get y by itself, then one of these other methods that we're going to learn might be quicker. So I'm going to show you another method today. We'll be doing a third method tomorrow. All three of them will work to solve systems of equations. You can either choose your favorite and just do that one all the time, or you can kind of let the problem dictate what you do. I do recommend that if you like graphing and you just want to do graphing all the time, that's fine. But also be comfortable with one of these other algebraic ways in case you don't have a calculator. Like if you forget one or something, you still need to be able to solve them without the calculator. Okay, so today we're going to be solving systems by, it's either called the elimination method or the addition method. So just be comfortable with both names. They mean the same thing. So how to solve by addition. All right, so the first thing you need to do when we are solving by addition, put the phone away please, is to make sure that both equations are in standard form. So if you remember what standard form is, that's when you have your x term plus your y term equals a number. So you want your x term first, then your y term equals a number. You want them in the same order for both of your equations. So in this example over here, we already have them in standard form. It's x, y equals number, x, y equals number. So we're good there. These are already in standard form. So now with this addition or elimination method, the goal is to add, hence addition method, is to add the two equations together, and when we add them to have one variable cancel out, which means we'll just be left with one variable, which makes it possible for us to solve for that variable. So in order to have a variable cancel out when you add the equations together, you will need to have one variable with the same number but opposite signs. Right, because if you have a positive 4 and a negative 4, if you add those together, you get 0. It'll cancel out. Or a negative 6 and a positive 6, if you add those together, you get 0. They cancel out. So to do this, you can choose what variable you want to cancel out. It doesn't matter what one. If you want x's to disappear, fine. If you want y's to disappear, that's okay too. However, sometimes it might not work out where they can cancel out right away, so you may have to multiply one or both entire equations by a constant. Constant is just a number, to end up with the same number but opposite signs. If you think about it, kind of like finding a common denominator, that's essentially what we're doing here. So similar to a common denominator. Okay, so what that means, if we look at this example over here, let's say we wanted the x's to cancel out. Right now we have a 2x in our first equation and a 4x in our second equation. So what can make it easier to choose what variable to cancel out is if you can multiply one equation by something to get the number in the second equation. So is there something we can multiply 2 by to get to 4?
Yes, there is.
Yes, there is. What can we multiply by?
3.
What?
2.
2, yes. Whereas if we look at our y terms, we have a 3 and a 5. Is there any number that we can multiply just the 3 by to get to 5? No. If we wanted to use addition method to get rid of the y, we'd have to multiply both equations by something. We'd have to multiply this one by 5 and this one by 3 in order to get them to cancel out. I'm actually going to do that way, though, just so you can see how it works. But you could make it easier on yourself and just do one equation. So both of these y terms already have opposite signs. We have a negative here and a positive here. So that's a good sign. We don't have to worry about negative or positives. But in order to have the same number with opposite signs, with a 3y and a 5y, the common multiple that they have is 15. So in order to get that negative 3y to be a negative 15y, we have to multiply this whole equation by 5. So every term, both sides of the equal sign, gets divided by, or gets multiplied by 5. We chose it because it is a common multiple of, because it will get us to 15, which is a common multiple of 3 and 5. You'll see in a second. So we multiply, we'll have 10x minus 15y. When you're multiplying, you can choose any number you want, as long as you do it to both sides of the equal sign.
So I can choose 27.
Sure. Might make your life a little difficult, but you could choose 27 if you wanted.
You know it's making my life difficult.
And then for the second one, so now we have our y term is a negative 15y. So in order, remember the goal is to have the same number but opposite sign. So that means we need this y term to be a positive 15. What do I need to multiply this by to be a positive 15? Positive 3. So we multiply every term, both sides of the equal sign, by a positive 3. So we get 12x plus 15y equals 9. Okay, so again, we did this in order to get the y's to cancel out. If you wanted the x's to cancel out, you could just multiply this top equation by negative 2. Then you'd have negative 4x plus 4x, which would be 0. So either way works. Okay, so now, once we have that same number, we both have 15, one is negative, one is positive. Once we have the same number but opposite signs, then step 4 says we're going to add the equations together and solve for the remaining variable. So if we go back over here, we add our equations together. Remember, when we're adding, we can only combine like terms. Gentlemen. So this is why having your equations both in standard form, the variables will already line up, so you can just add straight down. So 10x plus 12x gives me 22x. Negative 15y plus 15y gives me 0. We don't need to write anything because it's gone. Remember, that was our goal. If you add these two equations together and you still have an x and a y, then something went wrong. And then 35 plus 9 gives us 44. And so now we are left with only an x term. So how would I solve this for x?
You
Divide by 22.
You get all.
You get 2. So x equals 2. That is our x value. But remember, with a system of equations, you need an x and a y value. So here's my x. But to get my y value, if we look down here at our last step, you're going to, gentlemen.
I'm trying to catch up.
Okay, but you're also talking over me, which isn't going to help. So the last step here is you're going to plug the value for that variable into either equation and solve for the one you don't know. So we know what x equals. You can choose either one of your equations. I'll just choose my top one, but it doesn't matter. And I'm going to plug in a 2, because that's what x equals, in for x. So we'll have 2 times 2 minus 3y equals 7. You can do this multiplication. We'll have 4 minus 3y equals 7. And then we just solve for y. So we would subtract 4 from both sides. So we'll have negative 3y equals 3.
X equals 1.
Negative 1, because you would divide by a negative 3. So y equals a negative 1. So negative 1 is the y value of my solution.
All of that.
Can you scroll up so I can see the picture?
There will be a lesson video on methodorganetruby.com.
Nobody's going to hold that down.
That was rude. Thanks for that.
It's not rude.
Yeah, it is.
I'm sorry. You mean, bro.
Okay. So I know it seems like a lot and the directions have a lot of words, but really all you're doing is multiplying and adding, which isn't too bad if you think about it. So we'll do another example together. So example 1 here. Right now both of our equations are not in standard form. So, whatever. So we need to rewrite our first equation in standard form. So we already have our x term over here, which is good. But we need to move our y term over. And then we need to move that minus 13. So we'd add 13 to both sides.
You know what? I'm not gonna do this. I'm not going to look at that.
So we have 5x plus 2y equals 13. Our second equation already is in standard form, so we can leave it as is. 4x plus, I'm going to write 1y, just so I remember that's a 1 out in front, equals 11.
Isn't it 2 1? Oh no.
No.
That's the top equation.
Yeah.
Is that 11?
Yep, it's an 11. Okay, so looking at our two variables, we have a 5x and a 4x. And then we have a 2y and a 1y. What variable do you want to cancel out, x's or y's? Y's, okay. So we have a 2y and a 1y. What could we multiply this 1y by? 2, but we need it to be the opposite sign. So multiply by a negative 2, because this one's positive. So we multiply the entire equation by a negative 2, all three terms.
Negative 8x, negative 2y, negative 22.
I'm going to rewrite my first equation just on top. We didn't change anything there. Okay, so now our y terms have the same number but opposite signs. So we can add our two equations together. So 5x minus 8x gives us negative 3x. My y terms cancel out. 2y minus 2y is 0. And then 13 minus 22, or plus a negative 22, gives us negative 9. And now we're left with just an x term. So how would I get that x by itself?
Divide by negative 3.
Divide by negative 3 on both sides. So we get x equals positive 3. Okay, so I'm going to write my solution over here. So my x value is a positive 3. How do I get my y value?
Plug in 3.
Yes, you're going to plug in 3 for x into either equation. No, because a solution to a system is a point. You need an x and a y value. So you can plug it into either one. However, if we look at our second one, y is already by itself, which means it'll be easier to solve for y with this one. But you can really plug it into either one.
So 4, 3 plus y equals 11.
Yes. So we'll have 4 times 3
Negative 1.
plus y equals 11. 4 times 3 is 12.
Is 12.
Then we minus 12 from both. Darnell, please. 11 minus 12 is negative 1, which is our y value. So this would be our solution, the point 3, negative 1.
Easy.
Good.
The whole class had
I said negative 1. What do you?
Okay.
the world is not revolved around you. I still don't understand.
So example 2. This is now putting together what we did on Thursday, where we set up our word problems, but now we have the tools to solve them. So we're going to set this one up and then use addition or elimination to solve it. So example 2, Krista's school is selling tickets to a football game. On the first day of ticket sales, the school sold 8 adult tickets and 18 child tickets for a total of $150. The school took in $200 on the second day by selling 16 adult tickets and 16 child tickets. What is the price of one adult ticket and one child ticket? So remember, we look at our question. What is the price of one adult ticket and one child ticket to define our variables? So we can have X be the cost per adult and Y be the cost per child. Again, what variables you actually use doesn't matter as long as you define them. Okay, then we need to find our totals. So we have 2 different days that we're selling tickets, and they have 2 different totals. So this is one. They sold $150 worth the first day, and then $200 on the second day. So one of our equations will equal 150, and one will equal 200. So our totals are in the total amount of money. And so for each day, we have an amount of adult tickets and an amount of child tickets. So we take the cost per adult ticket times the number of adults. That'll give us our total cost for the adults. And we can do the same thing for the children. So for our first equation, it was 8 adult tickets and 18 child tickets. And then our second day was 16 adult tickets and 16 child tickets.
Oh my gosh.
Any questions with setting up the equations? Quinn, question? Darnell, question? Okay. So now to solve this by the addition or elimination method, we need to first choose what variable we want to cancel out. So do we want x's to cancel or y's to cancel?
We want Y's.
Okay. Okay, x's are easier, y or x is easier? Yeah, because if you look, what can you multiply 8 by to get to 16? 2. Getting 18 to 16, that's not going to work. You're going to have to multiply both equations by something. So you could do it. Your numbers will just get pretty big. You have to multiply both equations. Whereas here, to get x's to cancel, if you just multiply your first equation.
Sorry, I just want to challenge.
No, you're good. If you want to do it, you can. We'll get the same answer.
Hey.
If you multiply this first one by -2, then we have negative 16x and 16x, and we only have to multiply one equation instead of both. Okay, so we'll have negative 16x minus 36y equals negative 300. Then our second equation, we didn't change at all, so just copy it down. 16x plus 16y equals 200. And now we add our equations together. So we'll have a negative 20y, right? Because it's a minus 36y plus 16y.
Get a negative 100.
Mm-hmm.
Negative positive 5.
Yep. And then negative 300 plus 200 is negative 100. Divide by negative 20. We get y to equal $5. So, and it's $5 now. When we have a word problem, you have to put your answer in the context of the problem. So what did our y value represent?
$5
Per child, yes, $5 per child. What? Why?
You already know what we're solving for. Per child, just making a little extra ink and then not drop.
No, it's helpful because sometimes you might have flipped the variables from what I use, like on an answer key or perhaps on a quiz. So if you don't tell me what 5 is representing, I won't know. Okay. But that only tells us the cost per child ticket. We also need to know the cost per adult ticket. So now we can plug that value in for y back into either one of our equations. It does not matter which one. I'll just do the top one because it's first. So I'm going to plug in 5 for y. So I'll have 8x plus 18 times 5 equals 150. Then I get 8x plus 90 minus 90 from both sides. I get 8x equals 60. Divide both sides by 8. I get x to equal what? 7.5. So $7.50 per adult. Okay. Any questions? All right. So if we look on the back side, example 3a.
Green ghost.
Right now, our equation, our top equation there is not in standard form, so we have to rearrange it. If we subtract 4y from both sides and then add the 12 over, we'll end up with 3x minus 4y equals 12, and then our second equation is good. It's already in standard form. Okay, so now we need to choose what variable, x or y. Which one do we want to cancel out?
Money.
X? Okay. So what do I have to multiply the top equation by?
2.
Just a positive 2?
Yes.
Negative 2.
Why?
Because, remember when we add them together, they have to cancel out. So that means we have to have the same number but opposite signs. So since this one's a positive 6x, we need that one to be a negative 6x. So we multiply. We'll have negative 6x plus 8y equals negative 24. My second equation didn't change, so I'm going to copy that over. Yes. So we add together. Negative 6x plus 6x is 0. 8y minus 8y is 0. Negative 24 plus 24 is 0. Does 0 equal 0?
Yes.
Yes, this is true. So what does that mean?
Solution.
What about the solutions? How many of them? Infinite solutions. Infinite solutions. It's when everything cancels out. Everything. Okay, so in this case, everything canceled out. We were left with 0 equals 0. That's a true statement. That's why we have infinitely many solutions.
I ain't getting you a discount next time.
Okay, let's take a look at our second one here, letter B. Both of our equations are already in standard form. So do we want our x's to cancel or the y's to cancel? No, we want one. We gotta choose one. Which one?
Let's just do X.
Let's just do x. Okay. What do I have? Do I multiply the first equation or the second equation? By what?
By negative 2.
By negative 2. Everything.
Minus 2.
Okay, yeah. Wait, you're getting ahead of me. Hang on. So you have 6x plus 2y equals 15. That's our first one. It didn't change. When we multiply our second one, we'll have negative 6x minus 2y equals negative 14. And when we add together, the x's cancel and the y's cancel, which leave me with 0, equals 1. Does 0 equal 1?
No.
No, this is a false statement, which means what?
No soul, baby.
No solution.
We do the solution. We please do the homework now.
Exactly. Please.
It's-
I am unsure of or confused about this.
This is easy, Karen.
I'm ready to try.
Okay, good. So any questions
I'm
then?
gonna do the homework tonight.
Okay, quick question. How do you know every single time to multiply by negative 2?
Oh, it just happened to be -2 in this case. It didn't have to. Like for this top one, if we wanted the, or I guess those all happen to be
now I
-2.
understand.
It just, in this case, it happened to be -2 in both cases, right? But it's not always. You're just trying to get, guys, it's okay. You're just trying to get the same number opposite signs. So whatever you have to multiply by to make that happen.